In this, we are going to discuss on incidence, degree, order, neighbor, neighborhood, and many more. Incident is also known as adjacent. The idea of incidence is the idea of nearness. Two vertices are near or incident or adjacent if they are connected by the same edge, link, arc, or one simplex. In here we have a graph with four vertices v1, v2, v3, v4. As you can see, v4 is near to v1. It is also near to v2. It is also near to v3. Because v4 is connected to v1 by e1, v4 is connected to v2 by e2, v4 is connected to v3 by e3. Therefore, we can say v4 is incident on v1 by e1, v4 is adjacent with v1 by e1. Also, v4 is incident on v2, v3. In the same way, we can define the neighbors of v4 as v4 has three neighbors v1, v2, v3. Therefore, the neighbors of vertex 4 are v1, v2, v3 because they are connected by edge of e1, e2, e3. Where e1 has a endpoint of v4, e2 also has an endpoint of v4, and e3 has a endpoint of v4. Therefore, v1, v2, v3 are neighbors of the vertex v4. In the same way, we can define incident edges as if ei and ek have a common vertex, we say The edges EI and EK are incident, or EI is incident on EK. Or EI is adjacent to EK. For example, we have a graph of vertices V1, V2, V3, V4 with the edge of E1, E2, E3. As you can see, E1, E2, E3 has a common vertex V4. Therefore, E1 is incident on E2, E2 is incident on E3, and E3 is incident on E1. If we are given a set of E with E1, comma, E2, comma, E3, where E1 is defined as A, comma, B, E2 is defined as C, comma, B, E3 is defined as D, comma, B, E4 is defined as A, B, C, D, E, comma, B. To know whether or not E1 is incident on E3, E2 or E4, we have to look for the common element. Here, B is common in E3, B is also common in E2, B is common in E4. Therefore, E1 is incident on E3, E2, E4. We have to look for the common element. The degree of vertex. The degree of vertex or zero simplex is the number of one simplex incident with it where the loop is counted twice. The degree is also known as valency. It is denoted by degree, round bracket with a vertex V. Theorem: the number of vertices of odd degree in a graph is always even. For suppose you have to find the number of vertices in a graph where the degree is given. If the degree is odd, that is an odd number, then according to the previous theorem, the number of vertices will not be an odd number, or the number of vertices will be a even number. How to find a degree? So, the degree is defined as the number of edges incident on a vertex. Here we have a graph of 4 vertices A, B, C, D with the lengths of E1, E2, E3, E4. The vertex A is connected by E1. The vertex A is also connected by E4. Therefore, the degree of the vertex A is equal to 2. The vertex B is connected by E1. The vertex B is connected by E2. Therefore, the degree of B is also 2. The vertex C is connected by E4. The vertex C is connected by E3. Therefore, the degree of vertex 3 is 2. The vertex D is connected by E2. The vertex D is connected by E3. Therefore, the degree of the vertex D is equal to 2. A graph is called regular if the degree of all vertices are equal. In here, the degree of vertex A, the degree of vertex B, the degree of vertex C, the degree of vertex D are equal. Therefore, the graph is regular. Order is defined as the number of vertices in a graph. It is denoted by the absolute value of the set V. Again, the neighbor is defined as the two vertices are neighbor if they are endpoint of an edge. Here, V1, V2 are neighbor because they are connected with E1. Neighborhood is the set of all neighbors of the set V, denoted by n round bracket V. If we are taking a subset of A of V, then the neighbor is defined as and bracket A, and it is the set of all neighbors isolated vertex. If the degree of a vertex is 0, then the vertex is called isolated. If the degree of a vertex is 1, then it is called pendant vertex or end vertex. Isolated vertex, pendant vertex, degree is 0. In here, the degree is 1. Theorem number 1 is the sum of degrees is equal to 2 times the cardinality of the set E of a graph. That is, the sum of all degrees of vertex will always equal to the twice the cardinality of the set E, or simply 2E. What will happen if the degree of vertex 1 is equal to the degree of Vn and the degree is 1 and the remaining degree of Vk are 2? For suppose you have a set of V with V1 up to Vn, where the degree of V1 is equal to 1, the degree of V2 is also equal to 1, and the degree of the rest or the remaining vertices, that is the degree of Vi, is equal to 2, where I is not equal to 1 and I is not equal to n, or simply I is less than n but greater than 1. The answer is if the degree of the first vertex is equal to 1 and the degree of the last vertex is also equal to 1 and the degree of the remaining vertex Vk is equal to 2, therefore we get a graph that is known as path. Path is a graph where the first vertex, the last vertex has the degree of 1 and the degree of the remaining vertex is equal to 2. What is the sum of the degree of path where n is equal to 6? As we know by the theorem, the sum of the degree is given by twice the cardinality of the set E. Let P6 be a path of 6 vertices, then by the theorem, the sum of the degree is equal to the 2 times the cardinality of the set E. To find the set E, what we are going to do is to make a path. The first one is V1, last one is V6, V2, V3, V4, V5. The first link is E1, the second one is E2, E3, E4, E5. Therefore, the element of set E is ER, E1, E2, E3, E4, E5. The cardinality of the set E is 5. Therefore, 2 into 5 is equal to 10. The sum of degrees of Vi is equal to 10. The size of a graph. The size of a graph is defined as the cardinality of the set E. We can use the previous theorem to find the cardinality of the set E as the sum of the degree is equal to the twice the cardinality of the set E. Then the cardinality of the set E will be equal to the sum of the degree divided by the 2. And this will give us the size of a graph. What is a cycle? A closed path of n greater or equal to 3 is known as cycle. By close we mean the end point coincided with the starting point. Cycle is a path where the minimum number of vertices are 3, where the first vertex coincides with the last vertex. The graph 1 is a cycle. The graph 2 is also a cycle. The graph 3 is a cycle. As an assignment, read and write 150 words on Mendel's theorem